Hello. Today is the 20th of February and this is the late code POTD of the 20th of February. We have a question, find unique binary strings. Okay, this is the question number 1980. Okay, in this question what we give, we have given a array of string nums which has containing unique binary strings each of length n, and we have to return a binary strings of length n that doesn't appear in the nums. If there are multiple answers, you may return any of them. Okay, in this question we have given a array of strings nums. In this, let's suppose 0 1 1 0 is given in the string of in this string. Now we have to find the other string in this permutations. We have to return anyone. Okay, let's suppose what strings we can make. Okay, 0 1 1 0 1 1 0 0. Okay, so we can return 1 1 and 0 0 any of them. Okay, so both are our answers, 1 1 and 1 0 0. And how can we make strings? Let's suppose we are firstly read the constants. Here given the n is equal to nums dot length, and here n is 16, so basically very easy constants. And given that length of every string in the nums is n also, and nums is either 0 or 1. It may contain 0 or 1, mean a place in a string a place in a string can contain a 0, otherwise contain a 1. Okay, it may be either 0 or 1. Okay, and all the strings in the nums are unique. Okay, so what we can see that if it is a length of 2, nums length is 2, then it can make strings of length 2. 0 1 it is 2 length, 1 0 it is 2 length, 1 1 it is 2 length, and 0 0 it is also the 2 length. Okay, so we can say that the length of strings, the possible strings which can be of length 2 from 0 and 1 which can be made is either 4. So here are 2 and 2 are more possible, and 2 which are more possible is can be the answer, so you can see that 1 1 and 0 0. Now let's come to this case, 0 0 and 0 1. In this case 0 0 0 1 1 is given. Now what can be the answers, what may be the answers? 1 1 and 1 0. So 1 1 may be the answer, and you can return 1 0 also. Okay, this is also correct. Okay, and 1 1 0 1 1 0 1 1, now it comes to the 3 length. So we can see that the for 3 length it is supposed to be the strings of a 3 length. Okay, mean to 8 strings can be possible, because we know the condition. Actually you can see that, let's say we have 3 positions we have to fill. So we can fill it with the 0, we can fill it with 0 1 0 or 1. It can be 0 or 1, it can be 0 1. So 3 possibilities for 3 so 2 possibilities for every occurrence. So 2 to the power 3, because here 3 length. So we can see we can say that 8 possibilities can appear. So here 3 is given, we have to return otherwise 5, anyone from the 5. Okay, so 1 0 1 doesn't appear in the nums, these also doesn't appear, so these can be the correct answer. Okay, so we can what we can do this for question, we can just find all the approaches, all the possible which can be possible strings of 2 length or 3 length, which whatever we the given of the num size, we made all the strings, and just we save all these strings which have already given. We set into the map or set which whatever you want to take. I just take a map. Okay, just take a map or set wherever you can store these strings. Okay, and stores, and finally when you are generating strings, then check then it is in the map. If it is in the map, then continue. If it is not in the map, then just return, just save and return the result. Okay, let's just come to the code, what we can do. Okay, just 1 minute, I have to adjust it. Okay, yeah, now you can see that, suppose just 1 minute. Yeah, yes, so you can see that I take a initial n variable which take the size of nums. Okay, here which takes the size of nums. Okay, you can see that, and all the strings also of size n, because here here is mentioned that the size of every string is the length of size vector. Okay, and I take a map, you can take a set, otherwise also I just take a map. Okay, and just store all the strings in a map, and now I'm calling a function n map 0, and passing 0 is the index, and this is the empty string which is passing as a result. Okay, I checking current string. Okay, and finally I returning a result, and which I declared a global result as a global value, because okay. Okay, just come to the function. Here you can see that here I declare the result as a global variable. Yeah, okay. Now Let's just zoom it so you can appropriately see the function. Okay. Here is n passing, here the map, here the index, and the current string which are forming in the backtracking. You can easily approach these type of questions where permutations are forming. It is a backtracking question. Okay, easily founding. Okay, so I just what I do, I just do solve, call the functions with passing 0 initially and passing 1, and I doesn't initially current dot pop back because I doesn't explicitly pass. I doesn't directly pass in this. Okay, I doesn't explicitly pass. So I don't need to be this pop back. I don't need this to be pop back because I directly passes here. So directly passes here. So just don't need to remove it. Okay. So you can see that I just call this function, and finally in every iteration I'm going to increase the index, and when the index crosses n or is equals to n, I just check that the current string is forming is already present in the map or not. If it is not, then I just take it in the result variable and returning it. Okay, if it is not, I just return from the test case. Okay, and finally I submitted this. Finally I returning result here. Okay, the main function which will be given the find difference of binary strings. Okay, I just run this code. You can see that all the test cases pass. It is the complex, not just highly optimized approach, but the test cases all are passing here. Okay, okay, you can see that the not just a high, it is already just passed by steps. Okay, but this simpler approach which a beginner can understand and actually like the approach. Okay, and a beginner can build his confidence, okay, through this approach. Okay, if you like this approach and the way of explaining me and the strength and the way of the way of the approach, okay, then like the video and comment something good which motivates me. Okay, thank you.